video lesson, I wanted to discuss a C++ implementation of binary trees. So we can start by reviewing what we know about trees. So the general tree is a set T of one or more nodes such that T is partitioned into disjointed subsets. So a single node R represents the root, and the sets that are general trees are called subtrees of R. An n-ary tree is a set of T nodes that is either empty or it can be partitioned into disjoint subsets. So again, we start at a single node R, and there are n possibly many empty sets that are n-ary subtrees of R. T is a binary tree if T has no nodes or if T is of this form, where T sub L and T sub R are both binary trees. So they both start at the root, and T sub L and T sub R are both binary trees. A binary search tree is sorted according to values in its nodes. So for each node, a binary search tree has three properties. N's value is greater than all the values in its left subtree, that's TL. And then N's value is less than all the values in its right subtree, TR. So both of these, TL and TR, are binary search trees. And the height of a tree is the number of the levels of nodes that it has. So in this example, there's 1, 2, 3, height of 3. And in this example, there's 1, 2, 3, 4, 5, height of 5. Well, that's pretty easy. Let me close up a little bit more so you'll be able to read some of this. Okay. And I'm going to go ahead and we're going to start with the C++ implementation of a binary search tree. I'm going to close up a little bit. Okay, so I hope you can see that. So a struct node, this is going to be a node of a tree. So when we start, we're going to start with the root, and it's going to have a data field, and it's going to have a pointer to the left node and a pointer to a right node. And this is a member initializer list. So what this does, it's kind of like what the class constructor does, where it initializes values for the member variables of the class. In this case, we have a struct. So this is going to initialize the variables that are part of the struct. So when we start int value, we take a node with a value. The data portion is going to be the value, the left pointer points to null, and the right pointer also points to null. So that's what this does. And this code doesn't run properly without this member initializer list. So if you have problems with your code, remember that sometimes it's due to the fact that you need to initialize these values. Okay. And the next part of the code is going to represent the insert function. So when we insert, we set the root equal to a recursive function that's located below. So we insert a root and a value. And when we insert recursive, we have a set of circumstances. So the first circumstance is we're pointing to null. If we're pointing to null, it means that we could create a new node. If our value is less than the current node's data, then we recursively insert a node to the left. Else, if the value is greater than the current node's data, we recursively insert a node to the right. So I've actually created a traversal for it as well. This is pretty self-explanatory. I won't go over this one too much, but this just outputs the order that the nodes are placed. And then finally, the tree insert, the main code, which creates a binary tree, it initializes a binary tree, and we we insert 5, 3, 7, 1, 4, 6, and 8, and then we output the traversal. So I've actually created a listing for it. I wrote it out on paper. So when we start at 5, we create we do this if runs, and we create a node that stores 5, and that's the root, and the left and the right pointers point to null. When we insert the 3, 3 is less than 5, so we create, and then this would be empty, it's pointing to null, so recursively we're going to insert the 3, and then that node has 2 pointers that point to null for its left and its right edge. And then when we insert the 7 is greater than the 5. So we recursively insert the 7 into the right pointer. And then the member initializer list, it initializes both the left and the right pointers at null. Next, we will close up because this is a little blurry. So I hope you can see this a little bit better. But when we insert the 1, this is where we kind of start to see the recursion a little bit more clearly. So we start at 5, that's our root, and then we recursively have to travel through the tree. And we finally place, so the 3 is less, the 1 is less than the 3, so we recursively place it at the left node of the 3. And so on and so forth. So we have a 4, we have a 6, and then finally we conclude. Oh, there's a little cat stamp, sorry. We conclude at 8. So this is what the final binary tree looks like. And I can show you what the code looks like when I run it. Let me go ahead and debug. So yes, and that's what I was trying to do in the last video. I was trying to make this bigger. So I created a breakpoint so you can see how these are placed into the tree. So we start with a value of 5, and this creates the node for the root node for 5. I'm going to step over, and it gives it a location, and it initializes the left and the right to null. I'm going to step over again, and now we're at this command, binary tree insert 3. So I'm going to step into, step over. Here we go. So we're at 3, and we are going to place this on the left node of the 5. So you can see here, let me see. Yeah, okay, cool. It highlights over. So the data field is 3, the left is null, the right is also null. So when we move this, we establish this as the left pointer pointing to the node 3. And then so on and so forth. You can also run through this because I have put the code. I have put the code up so you can see what a C++ implementation looks like for a binary tree. And that pretty much concludes the video lesson. I just wanted you guys to be able to see it so that if you come across it, you've already went through what this does and kind of how to insert, but also to see how that insertion looks in code. So that's pretty much it. Thank you so much for listening, and have a wonderful day.